Today we're going to be looking at the perimeter and area of similar figures. So if the similar ratio of two figures is A divided by B, then the ratio of their perimeters is A divided by B. So if we're working with perimeters, we're taking the side lengths. The ratio of their areas then is A squared divided by B squared. So let's find the ratio of the perimeter of the larger rectangle to the smaller rectangle, and we're looking at perimeter. So if we're looking at the larger over the smaller. So we have the larger is 4 feet when the smaller is 3 feet. We could have looked at 12 feet over 9 feet. And when we reduce, we end up with 4 feet divided by 3 feet. Excuse me. For the pair of similar figures, we want to first A, find the perimeter ratio, and then B, find the area ratio. So let's start with A. We want the first figure to the second figure. Excuse me. So if we want the first figure, we have 16 yards to 12 yards. So if we reduce this, we end up with 4 yards to 3 yards. So this is our perimeter ratio. So now to find B, our area ratio, we're going to take our perimeter ratio and we're going to square them. So we have 16 yards squared divided by 9 yards squared. So then this is our area ratio. The areas of two smaller triangles are 49 centimeters squared and 16 centimeters squared. Now, what is the ratio of the corresponding side lengths? So, if we're doing the area ratios, we have 49 centimeters squared to 16 centimeters squared. So since this is our area, and we want to get to perimeter of the side lengths, we want to square root both of these numbers. So the square root of 49 is 7, so that means we have 7 centimeters over 4 centimeters. Here we have a slide that is 3/8 inches by 3/4 inches, and it's being projected onto a screen that's 3.5 feet by 7 feet. But what we want to make sure is we stay in the same units, since here we're working with inches. 3.5 feet is 42 inches, and 7 feet is 84 inches. So we want to know what's the ratio of the area of the slide to the large image on the screen. So the slide, we have 3/4 of an inch to 84 inches. So to find the area, we're going to square both. So 3/4 is really 9/16 because 3 squared is 9, 4 squared is 16 inches squared, to 84 squared, which is 7,056 inches squared. The area of the smaller figure is 10 inches squared, and we want to find the area of our large figure. So first let's write our perimeter ratio, and we're going to do from small to large. So let's say it's 2 inches to 5 inches. We can't reduce, so from here, since we're going to need to find the area, let's square both. So we have 4 inches squared divided by 25 inches squared. So we're using the ratio of 4 to 25 for our area. We know the small area is 10, so since my small is in our numerator, I'm going to write 10 in there. But we do not know what the area is for our large figure, so we're going to create a proportion, and we can cross multiply. So 4 times x is 4x, 25 times 10 is 250. and we can divide both sides by 4. So x equals 62 and 5/10 inches squared. So that means our large figure has an area of 62 and 5/10 inches squared.